Hey guys, welcome to session 6. So in the previous session, we learnt about classes and objects and instance variables and how we can access instance variables, and also how we can declare some of the variables as static, and we can access them at class level. So similar to the instance variables, we also have the methods in a class, which are basically functions similar to functions in C and C++. So a method basically has the following structure. It has a return type. So if it is returning something, we need to specify what type of what is the data type that it is returning, and then the method name, and then parentheses, and you can have arguments, or you may or may not have arguments, so that is not mandatory, but everything else is mandatory. And if you are not returning anything, then you just have void. So let's just write a simple method like this, void do something, and let's not pass any arguments for now, and let me just print something here. So similar to how we access the variables, we can also access the method in the following way. Do something. So when I run this, it is just going to print that do something. I'm doing something. So similar to how we can make the variables as static, we can also have the method type method to be a static. Uh, so if we use the static keyword, then one thing is it became italicized, indicating it's static, and you can access this with the object, or you can just access it at the class level, just the way how we access the variables. Okay. One other important thing is a static method can only access static variables within the method. So it does make sense, right? Because it's a class level method. A class level method can only access class level variables. It cannot access any particular instances variable. So if I try to access uh, color here, color is an instance variable, so I cannot set color to something like color is equal to black. So it gives me a syntax error here. It would say that color change modifier of color to static. So instead we can always access the number of tires variable. I can just increment the number of tires like this, and it will not give me any error. So similar to how we can access only static variables, a static method can only call another static method. It cannot call stop here. For example, we cannot call stop like this. So instead, if we had another static method, something like static, um, let me return something. I can give you an example of a method which returns something. Let it return a primitive type of int. Give me a number, and let's not pass any arguments for now, and this will just return a number, and let me just print that number here. So within the print statement itself, I can call this method. Since it's a static method, I can just call it at the class level like this. So now when I run this, so it's going to print I'm doing something, and also it's going to print the number. Okay, now that we are familiar with methods and variables, let's explore another important concept in Java. So we have heard about arrays, right, in other programming languages like C or C++. So similarly in Java, arrays represent a collection of same data types. So an array is basically a homogeneous structure which holds a list or a collection of similar objects. So let us say I have a bunch of cars. I have a showroom which represents 10 cars. So I can create an array of objects, car objects, by defining it like this. So we have the data type and then square braces, and then we the name of the array, and then we use the new operator, and here we are already allocating 10 memory locations for a data type of car. So we could have also declared it something like this. We could have declared it like this, and then we would not have been allocating the memory location at that time. But here we are predefining the size of showroom to 10. So once you create an array like this, you need to populate the array by using the indexes of that array. So we use a for loop for that, because creating 10 showroom of 0, showroom of 1, and so on, it will take a lot of space. So we just use a for loop like this, and we iterate from 1 to 10. So we are initializing I, and we are checking if it's less than or equal to 10, and we are looping it, and for every iteration we are incrementing I. So we are starting off with showroom of I minus 1. So 1 minus 1 is 0. So for an array, the starting index will be 0. It starts from 0 to the size minus 1. So 0, and we use the new operator to create the new car object, and we are assigning it to showroom of 0. And showroom of 0, okay, I added one more variable here called as car ID. So we are just assigning the ID to I. So for every car that is creating, we are just assigning one number. So you can think of it like a number plate for the car. So when we create it like this, we will be creating 10 different cars, and everything is stored in the array showroom. So this is one way of defining an array. And the other way, if you have a primitive data type array, something like this, you can, on declaration itself, you can assign the values like this. If you know that the values are like hard binded values, then we can just assign them like this. And similar to how we populate the array, we can even access the array like this. We create a for loop, start with 0 and less than 3, and increment I, and we just print a of I. So for every iteration we are printing a of 0, a of 1, and so on. So if I just run this, it should print 1, 2, and 3 in different lines. Okay, there's a null pointer exception here. Let's see what's wrong. So showroom of ID, showroom of, okay, this should be I minus 1. So that was a mistake. So it's just displaying 1, 2, and 3. Here we are just populating, we are not displaying the cars values. So one another interesting advantage of static is, let us say we have a static variable, something like instead of number of tires, let's say number of objects. And let me initially have this value at 0, and in the constructor let me just increment this number of objects. So what I'm saying here is, whenever an object is created, this constructor will be called. The parameterless constructor is always called whenever an object of car is created. For every object I am incrementing, so I'm starting with 0, and for every object I am incrementing this number. So this number basically keeps track of how many objects of type car is being created. So at the end of all of this, if I just want to print it, so I can have something like number of cars created equal to car dot number of objects. So if I just print this, So the 11 cars are created. Let's see how it is 11. So 10 cars are created here itself. In the showroom we have 10 cars, and we have a BMW car and an Audi car. So for BMW, for the Audi car, we are calling the a parameterized constructor. So the number of objects has not been incremented. So this is an error. So what I should be doing is I should be uh, incrementing the number of objects like this, even in the parameterized constructor. So when I run this now, it will display that 12 objects are created. So this way we can keep track of all the objects that have been created for a particular class. So that's it for this session. Thanks for watching.